Hello everyone. Today I'm going to talk about the specific question around the system design of WhatsApp. So as we know that system design is not about reading a particular solution and taking those solutions as a face value, but rather they are generally discussion between two or multiple people where a solution is thrown upon and then you try to see whether this solution actually maps to the requirement or not. So these discussions of system design can happen anywhere. They can happen in an interview room. They can happen in your workplace where you are pitching a solution. You are saying that, hey, let's use Redis or let's use this Kafka and build a solution. So in such cases, taking things as a face value from internet is not enough. You need to scratch the surface. You need to go one level beyond and see whether this solution is good for you or not, or why this solution should be chosen compared to some other solution. So one such question around this is whether one should use Redis or Kafka in their chatting application like WhatsApp. So let's deep dive into it. Before deep diving into the problem statement, let's first see what Redis and Kafka are. If you are already aware of this concept, then you can skip this section and move to the next section which I have mentioned in the timeline. So let's see what Redis is. So if you go to the Redis document, it is a in-memory database. By in-memory database, that it means that it keeps data in memory. It doesn't keep in disk. It keeps in disk, but when it serves you the data, it keeps in memory. So it is very fast. It was primarily used for caching. The Redis cache is something which you have heard, which you would have heard a lot. So it is used there. But there is one surprise, or for many of us, that Redis is not just used for caching, but it is used for many of the other purposes as well. It is used for pub sub model, that is publisher and subscriber. It is used for transactions. So it is used for many other places and not just for caching. And coming to Kafka, if you see Kafka, it's also quite popular technology which is built by Apache. But it is so popular that there are a lot of distributions of Kafka built by Confluence and other parties as well. So what is Kafka? Kafka is a streaming service. It's a publisher subscriber model again, where you publish a data to a Kafka topic. That is, you publish a data and then you can consume a data. So just like in Redis, you have a publisher subscriber Redis solution available. You have a publisher subscriber available in Kafka as well. But there is this one difference between the two, which makes them entirely different solution and if entirely different use case, is that Redis is in memory, but Kafka is not. Kafka writes messages in the disk. So if you publish a message to a Redis, it will be pushed in memory, possibly in the network buffer, and then pushed to the subscriber. But in case of Apache Kafka, when you publish a message, it gets written to the disk. And these operations are asynchronous. So the write happens on the disk, and then there are consumers who could consume from the disk. So the advantage of that is that the consumer, even if the consumer is not live, consumer is dead, and then they wake up one day, they can consume all their messages, even if the messages were delivered some time back. But that's not the case for Redis. So Redis doesn't store any message. They have pub/sub model, but they don't store anything. You send a message to Redis, the publisher sends a message to Redis, and it will be in memory and it will never be stored in a disk. And the communication will be as if it is over the wire from the publisher to the subscriber. So it is very fast because there is no disk operation, it's all in memory, whereas in Kafka it's stored and persisted in a disk. So when it's persisted in a disk, you need to allocate some space for all the topics which are created, and using the disk operations, these things are accessed. So these are the net difference between the two, which will be the pivotal point of the design choices which you would make. So I think now we are clear with both Redis and Kafka, at least the basics of it. You can of course go ahead and read about them and see what Redis and Kafka are. But for the sake of this particular problem statement, this much should be enough. Now let's move to the problem statement. The problem statement is simple, that you have Alice, you have Bob, and you want them to chat with each other. That's a simple problem statement. You want to have a text-based communication. It can be a chatting application, but you can also have a gaming application like chess as well with a similar problem statement. It must be a low latency, and the messaging will be frequent. So Alice and Bob are the people who would keep on messaging each other. So if you see here, Alice sending message to Bob. So one of the design choices is to have a backend, and via backend they can communicate with each other. And since the backend could horizontally scale, there would be multiple backends. So they would need a database, or they would need a storage where they could publish and receive the message. So that's the design choice we are taking. So if there are multiple backends, they would publish a message and they would consume a message. Now, when we see publisher and consumer, we would want to know whether to use Redis or Kafka. So let me just expand this problem statement a little more. So this is the exact solution which you would find online in a lot of places, that in such case you will have multiple backend machines. So this layer can scale itself horizontally, and this Redis is also horizontally scalable. So, and of course the users are they can scale as much as they want to. So there would be Alice, Bob, and Eve, and other people would be chatting with each other. So there would be a lot of users. These backend services can horizontally scale, and you can use Redis as a solution. So this is a typical solution available for a chatting application. And what you do is whenever two people communicate with each other, you publish the message to a channel 1. So Bob is connected to a backend machine 1, and Alice is connected to backend machine 2. If they are connected to the same machine, you don't even need Redis or anything, because that machine can do a lot of in-memory operations. But these layer also has to be horizontally scaled. So Bob will send a message to backend 1, and then back from backend 1, the message will be published to Redis. And then from Redis, the message will be published to backend 2. In fact, backend 2 would be subscribing to that same channel, and then Alice will get the message. So you see there is one connection between backend to frontend, and there are two connections from Redis. So one is for publishing and the other is subscribing. So yes, you need to have two connections to Redis to do the consumer and subscriber stuff. Now the natural question which you might stumble upon in any discussion room is, why do you want to use Redis for publisher subscriber? It's counterintuitive. Most of the cases is something using Kafka. Many places you would have seen, or it's quite popular to use Kafka as a streaming service. Why on earth we want to use Redis? So this is the exact question we will try to answer. So for that, what I have done is I have made a setup on my local for both Redis and Kafka, so that I can explain a few of the differences by running the code, so that once you run the code, you can see by example that, hey, this is the exact difference which we can observe between the Redis and Kafka. Although bits and pieces we have already discussed, but let's just see the exact difference around the both. So let me first share the setup which I have done for Kafka. So I have started my Zookeeper. So when you run Kafka, you need to do two things. You need to start a Zookeeper, and then you need to start Kafka. And then you need to create a topic on which you would be publishing and subscribing the message. So here, if you see, I have started my Zookeeper. I have started my Kafka as well. You can find a tutorial online. It's straightforward to download and run the Kafka. I'm not going to waste your time on this. And then what I have done is that I have created a topic. So it's a simple command to create a topic, Kafka topic create, and I have already done that. So the setup of Kafka is done. You create a topic. You are now ready to publish and subscribe to the message. So this stuff is done, and then I have started a producer and the consumer in Kafka. So you can see that I have started a consumer. If you see here, Kafka console, this is the producer, and this is the consumer. So both the things are ready, and they both are ready to publish message to each other. So the first thing first is that creating a topic. Whenever you create a topic, a lot of messages do get populated. So if I just run, just hold on, clear. If I run this and let's say I create a topic 1, anything. So you would say it's a heavy operation, and you would see a lot of logs getting populated whenever a new topic is created. So it's a heavy operation. It's not as simple as just calling the API. There is a lot of backend operations which are done. So, and now let's move on to the chatting part, or producer and consumer part. So let's say this producer wants to send a message, hello. You could observe, I'm sure you would be able to observe, there is some delay in the time, at the time when the message is sent and at the time when the message is received. Okay, so you can see the publisher and subscriber model of the Kafka. And similarly, we can move to the Redis. So I have set up Redis on my machine as well. You can install Redis. It's quite straightforward. You can go online and see how to install Redis on local. I'm again not going to waste your time setting up the Redis. So I have started my Redis server, and then again, this is what I have done. I have subscribed to a channel. Here, the one interesting thing is that you don't even need to create a channel to subscribe to a channel. You can subscribe to any channel you want to. It won't exist anywhere. It's just a channel, and all the operations will happen in memory. So I have subscribed to a channel 1, and if I publish a message, hello, it instantaneously comes here. So you see message, it's a message of type message on channel 1 because I have subscribed to channel 1. I could subscribe to multiple channels, and the message is hello. If I again type something like, how are you? You see, the message is instantaneous. It's very fast, and this is how the publisher and subscriber model of the Redis is working. I am able to publish to a channel, and the message goes to the channel, and the subscriber is able to see the message instantaneously. Why instantaneously? Because Redis is all in memory, whereas in Kafka it was not all in memory. It was going to a disk, and then from the disk it was reading and then giving you the data. So net you can see both the publisher and subscriber model in Redis as well as in Kafka. So now we can go ahead and compare the differences between Redis and Kafka in terms of chatting application. So the first thing first, we can see that Redis is the right choice in our problem statement here. And the main reason for this So there are four reasons. The first reason around this is that Redis is faster than Kafka. So you want to have a fast application. You want to have an application where the chatting happens very fast. You don't want the disk operations to happen. So Redis is faster. So if I publish any message from the publisher, it is instantaneous. Whereas if I go to Kafka publisher and subscriber, it does take some time to reflect. So it's less faster compared to Redis, and we want the communication to be faster. And we can't do that in case of Kafka. Of course, there would be some, at times it would be acceptable to have a delay of 1 second or so, but the operations are always asynchronous. That is publishing to a file and then reading from the file or disk. So that's the first thing where the problem arises. And the second is the cost of creating and cost of creating a topic. So if you see here, when I was creating topic in Kafka, or I can create one more such topics here. Let's say I create a topic 2. It does do some disk operations. You see that, it's trying to create some space and some partition, some space in the partitions, and Kafka would have multiple partitions. So the creating of Kafka topic is not a trivial thing which you would do here and there. That is, it is not going to happen that person one, Alice, wants to talk to Bob, so creating a Kafka topic is something which would be needed, which would be done, because at times those operations can be heavy. These are the persistence layer where these things would happen. So of course, instead of doing things in memory, you are now allocating a space in the Kafka cluster in different Kafka machines. So there would be multiple machines in the Kafka cluster as well, and you would need to propagate that message that a topic is created. And at times it can take some time also. It's not going to be instantaneous, just like this, just like the local machine. So it will take some time for the Kafka message or the Kafka topic to be created. So of course, it's not something which you would want. Whereas if I move to Redis, you see here, if let's say I pause it, and I pause both producer and consumer. Let me just clean it. And now I want to see, I will connect to Redis on my local, and then let's say I subscribe to any channel I want. So I have subscribed to this channel, any channel. This is the first thing which gets printed, which means that you have subscribed to any channel. And here I can publish to any channel. I don't even need to create a channel. I can just send a message and it's all in memory, and it's even faster. So there is no space requirement. These two are entirely different problem statements. One is the Kafka, which is all around the storage part, where the moment you create a Kafka, you would need to deal with the partitions. You would need to internally, it will shard. It will take the concept of sharding, that it will distribute the data into different partitions within the cluster. So a lot of heavier operations would be done. It won't be just a simple command being run. It will do a lot of things in the background, but whereas here you don't even need to create a channel. So the storage requirement, that's the second part. There is no third part. In fact, there is no storage requirement in case of Redis. You don't need to store the message, whereas in Kafka you would need to store the message. You can set the retention policy by default. Generally they are 7 days for Kafka, but Kafka solves a different problem and Redis solves a different problem. So for chatting application, again, Redis is a good choice. So the first is around the storage. The first is around the speed. The second is around the storage. And the third is around the cost of creating the Kafka topic. So you can see that cost of creating a Kafka topic is much more than cost of creating the Kafka. There is no such cost in case of Redis. Now the last point, let me move to the last point here. So we have already talked about the faster communication in Redis, no storage, and creating a Kafka topic. The last is cost of deleting a topic. So what if Alice and Bob, they were chatting and then they said, hey, good night and we'll talk tomorrow. So would you want the space to be allocated for Alice and Bob, the Kafka topic? You would want to delete it, and next day when they come live, you would want to connect them again because it's a real-time chat. So in case of Kafka, cost of deleting a topic is more. In fact, let me just share a couple of articles which I went through, and I found that the deleting of Kafka topic is not straightforward. It is something which might require some work as well. So there is this command to delete a Kafka topic. You can just run this command and you can delete. But even before doing that, you need to enable the deletion of the Kafka topic. So specifically, you have to go to a Kafka property and enable the deletion of the topic. And then you need to run this command to delete it. Also, it would happen that at times the deletion wouldn't happen, or it will take some time. It will be an asynchronous operation and it will take some time to get the topic deleted. But even if it doesn't happen, in case the topic deletion doesn't happen, then you have to go manually and you have to manually delete the topic by logging into the server. And eventually you might also have to restart the Kafka server. So here in the accepted documentation, if you see accepted Stack Overflow answer, that's what they mentioned, that you have to specifically stop the Kafka server and then get rid of topic. So you see that there is a lot of inertia, or there is a lot of hindrance in creating a topic and deleting a topic. And yeah, it is straightforward, but it is asynchronous and it will require some effort to be done. And that is something which you would not want to do all the time, that hey, let's create a topic when Bob wants to talk, and let's delete it when they don't want to talk. So in such cases, having a Redis solution is much better. So if you just see the Redis, I can just publish to any channel I want to, and I can publish to channel 1. Now, since there is no subscriber of channel 1, you don't get any message. But now if you subscribe to channel 1, so you wouldn't get the previous message as well. That facility was there in Kafka. That is in Kafka, the consumers can start and they can read the message even before they were created. But in case of Redis, they are just lost. So Redis is all about the performance. Redis does not take into the consideration of the storage of message, and yeah, it solves altogether a different problem. So if now again, if I publish a message, you would see the Redis accepting the message. So now if you see the system design diagram which we were talking about earlier, so you can publish a message to a Redis channel, and if there is a third person like Eve, and that person is connected to one of the backend machines, so you can create one more channel. And by creating a channel, I mean that you don't even need to create a channel. They would just be connected by Bob sending a message to some channel, and other consumer would receive to, let's say, channel 2. So that's how the design of Redis is, and that's how the design choices can be made here. Now there is one more question which people can ask, that hey, I want to store my messages as well. That is, if Alice and Bob wake up in the morning, they should be able to see what chat they did a day before yesterday. So that's a different problem statement. It cannot be clubbed with the communication problem statement. That's a storage problem. And for the storage problem, there are multiple solutions. One is storing at the server end, and for that you can have a Kafka consumer or a Redis consumer, and that consumer can put the data into their database. Or you can even store the message in their own machine, just like WhatsApp does, and then sync that message to Google Drive or iCloud. So that's a storage problem, and that should be solved separately. If you try to mix two different problem statements, then a lot of confusion arises. So that's all for this video. I hope I was able to clarify when to use Redis, and specifically why to use Redis in a chatting application. At times it's important for us to scratch the surface and come up with the reasons, because in system design it will happen that you throw a solution, the people are going to ask you why you have given a particular solution, why not something else. You read online that hey, use Redis for a chatting application, they would ask you why not Kafka, or why not a NoSQL database. So having a proper justification will help you to be more convinced. And of course you should try out these Redis and Kafka, and then experiment and figure out as well. I will also share some of the commands, and you can run those commands on your machine to see how they are performing. That's all from my side for this video. I hope you like it. If you like it, please like and comment. It really makes a difference. Till the next week, bye.